Hey everyone, welcome back to Python's AI Talk. This is day 4 of our generative AI journey. In day 3, we learn how to handle missing values using mean, median, and mode. Today, we will learn another technique called KNN Imputation. Then, we will understand how to convert categorical data into numbers using label encoding and one-hot encoding. And finally, we will apply everything particularly using Python. So let's get started. First, what is KNN? So KNN stands for K, nearest neighbors. K means the number of neighbors we want to consider. Nearest means the most similar data points, and neighbors nearby data points we use to make a decision. In simple words, KNN looks at similar examples and learns from them. Let's understand this with a simple example. Imagine a new person apply for a loan. We compare this person with other people using information like salary, credit card, and previous loan data. KNN find the most similar people, check their results, and then make a prediction. But how does KNN know which data points are similar? So it calculates the distance between them. A smaller distance means the data points are more similar. So KNN calculates the distances, find the closest point, and chooses them as neighbors. Now let's understand K. K simply means the number of neighbors we want to consider. If K equal 1, we look at one nearest neighbor. If K equal 3, we look at 3 nearest neighbor. And K equal 5, we look at 5 nearest neighbors. For a classification problem, KNN can use majority voting. Suppose K equal 3. Among the 3 nearest neighbors, 2 say no and 1 say yes. Because the majority say no, the final prediction is no. It's like a small vote among the nearest neighbor. So choosing K is important. A very small K can be too sensitive to usual or noisy data, but very large K may oversimplify the pattern. Common starting value are 3 or 5. Later, more advanced techniques can help us to choose a better value of K. Now let's connect KNN with missing values. KNN imputation fills a missing value using similar data points. First, it finds similar rows. Then it chooses the K nearest neighbor. Finally, it uses information from those neighbors to estimate the missing values. And here is the simple difference. Mean imputation use the average value. Median imputation use the middle value. But KNN imputation uses similar data points. So KNN use the surrounding information in the data instead of using one single value for everyone. So there are a few important things to remember. KNN works with numerical feature because it uses distance calculation. And common K value are 3 or 5. Relevant feature help KNN find better neighbor. And on very large data set, KNN can become slow because it needs to calculate many distances. Now let's move to data encoding. Real data sets often contain text categories like male and female, small and large, or different city name. But machine learning models need numerical data. So we convert categorical data into numerical form. This process is called encoding. Before choosing an encoding technique, we want to understand two types of categorical data. So ordinal data has a meaningful order, for example small, medium and large, but nominal data has no meaningful order, for example red, blue, green. This difference helps us choose the right encoding method. Then the first technique is label encoding. Label encoding gives each category a numerical value. For example, female may become 0 and male may become 1. So each category gets one number. One important point, these numbers are only codes. If female becomes 0 and male become 1, it does not mean one category is better or greater than another. The numbers are simply used to convert text into a format the model can process. And the next technique is one-hot encoding. Instead of giving every category one number, one-hot encoding creates a separate column for each category. Each new column contains 0 or 1. 1 means the category is present and 0 means it is not. So here the easy difference. Label encoding converts each category into number. One-hot encoding creates separate column. When categories have no meaningful order, one-hot encoding can avoid creating an artificial order. Now that we understand the concept, let's apply everything particularly using the Titanic dataset. First we will load the dataset and check the missing values. Then we will apply KNN Imputation. After that we will convert categorical data using label encoding and one-hot encoding. From this point onward we will go through the code one cell at a time. So let's start coding. So first we import OS and Pandas. OS will help us find the CSV file and Pandas will help us work with the dataset. Now let's see. I am searching through this folder to find the CSV file automatically. Now we load CSV file using Pandas and store it into data frame called df. Let's use head to preview the first 5 rows of our dataset. This gives us a quick look at the column and values. Now we use is null parenthesis dot sum parenthesis to check the missing values. Here we can see each column contains missing values. In day 3 we filled each using the median. Today we will try KNN Imputation. Before changing the data, I am creating a copy called df_KNN. This keep our original data set unchanged. So KNN finds neighbor using numerical data. So here I am selecting age along with other numerical features like age, fire, PC class. Features give KNN more information for finding similar rows. This is better and more correct than using only the age column. So here we can see the numerical data selected for KNN Imputation. Before applying the imputer, let's check the missing values in our selected data. We can see age contains missing values. Now we import KNN Imputer from Scikit-learn. Now we created the KNN Imputer. n underscore neighbor equal 5 means it will consider 5 nearest neighbor. Now we use fit underscore transform. KNN looks at the numerical features, right? Find similar rows and fill the missing values using the nearest neighbor. So let's check. Then the imputer return numerical data. So now we convert the result back into a Panda data frame and keep the original column name. Now we take the field age value and put them back into our data set. And finally we check the age column again, and 0 means the missing age values have been successfully filled using KNN Imputation. And here we can see the age values after imputation. Now let's move to encoding. The column contains text categories, so let's convert them into numerical value. First we import label encoder from Scikit-learn. Now we create our label encoder. Now fit underscore transform converts the text categories in the column into numerical value. Now we compare the original values with the encoded values. Here each category has been converted into a number. So next let's look at the embark column. It contains categories like S, C, Q, and these categories do not have a meaningful order, so we will use one hot encoding. Before encoding, we first fill the missing embark value using the mode. Now we use get underscore dummies to apply one hot encoding. This creates a separate numerical column for each category. and here we can see the new column. 1 means the category is present and 0 means it is not. And finally, we are combining all the process data into one final data set using pd.concat. Here axis equal 1 means we are joining the column side by side, so our clean data set and the encoded embark column are merged together. Next, I'm using df_final.head to preview the first 5 rows and verify that everything has been combined correctly. See. I am printing the shape of the dataset using df_final.shape. This tells us the total number of rows and column, confirming that our pre-processing is complete and the dataset is ready for machine learning. And that's it for day 4. Today we learned what KNN means, how it finds nearest neighbor, and how the value of k work. Then we use KNN Imputation to handle missing age values using similar numerical data. We also learned why machine learning models need numerical data and understood label encoding and one-hot encoding. Finally, we apply everything particularly using the Titanic dataset. If you completed this lesson with me, comment day 4 complete below. Like the video, subscribe to Python's AI Talk, and I will see you in day 5. Keep learning, keep building, and keep moving from Python to AI.